This is our ErgoCarbon workspace. So for the early part of our semester, a lot of effort went into creating the tooling for a Z-shaped tabletop. We used a cardboard core cut to size with wet lip glass fiber epoxy. To prevent warping within the cardboard due to curing, this is a lengthy stepwise process of wetting out glass fiber on a separate surface and transferring to the cardboard. The cardboard glass fiber tool was created to the same thickness as our honeycomb core, which allowed us to directly lay up our carbon fiber tabletop on each side of the tool under vacuum.
Our base plate was a simple carbon fiber sandwich panel laid up to the same overall length and width of our tabletop to create a flush finish when fully lowered. Our struts were created from a wood core and a carbon fiber sleeve wet out on a filament winder. These were machined to create ends with a specified radius and drilled holes for our assembly rods. 90-degree carbon fiber support brackets were laid up on the corners of our original glass fiber epoxy tool and machined down to size.
Additional processes included welding our threaded rods and 3D printing our wheel housings and crane handle. With all of our manufacturing parts and few purchase parts such as bearing, nuts, bolts, and washers, we were able to fully assemble our first article unit.
With a fully assembled prototype, we were able to begin qualification testing. We performed 6 tests based on our design concern table that was made during first semester. So the first design concern was that the table should be lightweight. This is due to competitor desk risers typically seeing high weight in hydraulic metal mechanisms. It is important to limit the overall weight when portability is required. Instead of buying a full standing desk, there should be customer appeal in a lightweight portable alternative.
The next concern was to ensure that the mechanism used had adequate stiffness to ensure the mechanism was sturdy enough for everyday use. This was done by adding 150 pounds of weights to the top of the tabletop and measuring the displacement. Another design concern was if the tabletop was going to be stiff enough to prevent noticeable bending. To do this accurately, we made a flat 4-point bend specimen that had the same layup as our tabletop.
Using more of the samples made from the previous tests, we made sure that our parts could withstand coffee/water and other liquids. We checked on the amount of flexural strength retained after being submerged in water for 5 hours. We also wanted to check that our tabletop would not be scratched easily, so we checked the hardness of the carbon fiber epoxy surface. Finally, we used the drop weight tester to ensure that the commonly dropped coffee mug would not hurt the tabletop.
Now what you've been waiting for, ErgoCarbon Workspace in action.